A single supplier wins a national contract. The decision looks efficient. Decades later, every replacement part carries a price no one anticipated. A procurement committee selects one manufacturer for all national orders. The choice removes duplication. It also removes the ability to switch. In the post-war period, national budgets face enormous pressure. Governments must rebuild infrastructure quickly and at the lowest possible cost. Standardization is the tool governments reach for. One specification means faster ordering, simpler training, and predictable costs across all regions. The savings are real and immediate. A unified specification reduces errors, cuts negotiation time, and lets planners predict budgets years in advance. Alternative suppliers are removed from consideration. Each one eliminated reduces procurement complexity. The network of options narrows to one path. The supplier now holds a unique position. There is no competitor qualified to fill the same contract. The network depends on a single production source. Years pass. The contract renews automatically. The terms do not change because there is no competing offer to test them against. The supplier has no reason to reduce prices. The buyer has no leverage to demand them. The relationship stabilizes at a fixed cost level permanently. The network grows larger. More stations connect. More lines extend outward. Every addition is built around the same single supplier specification. Each expansion embeds the original specification deeper. Compatibility becomes the constraint. Any deviation now requires replacing what already exists. This is called path dependency. Early choices define which later choices are available. The range of options shrinks with every year of operation. The supplier understands its position. It does not need to improve its product aggressively. The network cannot afford to switch regardless of performance. The original planners are long retired. The institutional memory of why the specification was chosen fades. Only the specification itself remains active. New engineers inherit the system. They maintain it as designed. Questioning the specification requires justifying a replacement, cost no one has budgeted. The supplier raises prices modestly each cycle. Each increase is small enough to approve without escalation. Together, they compound into a significant margin. The approval process is built for small decisions. Large structural questions require a different process that no one has initiated. The small approvals continue. Switching costs are not visible in any single budget cycle. They exist only as a total that no one is required to calculate until replacement becomes necessary. The network now spans the entire country. Thousands of identical components operate daily. The specification has become the physical reality of the infrastructure. Future videos on this channel examine how similar decisions in other industries shaped outcomes that unfolded over decades rather than quarters. The original manufacturer begins to age. Its workforce shrinks. Its tooling wears. But the contract continues because no alternative has been approved or prepared. A component reaches the end of its service life. A replacement order is placed. The supplier quotes a price that reflects its unique production position. The price increase is significant, but the operation cannot stop. Running a network without replacement parts is not an option administrators can choose. The cost is approved. The order is filled, but the price increase multiplies across every future order for every identical component across the entire system. The concept at work here is called captive demand. When a buyer cannot substitute, the seller determines the price. Volume amplifies the effect across all units. Budget planners begin to notice the drift. Each renewal cycle costs more than the last. The increase is explainable, but the trajectory is now established and self-reinforcing. An internal review proposes sourcing from a new manufacturer. The proposal requires capital investment, requalification, and testing across every existing installation. The requalification cost exceeds the projected savings. The review concludes that switching is not economically justified under current conditions. The contract continues. This calculation repeats every review cycle. Each time the switching cost grows larger. Each time the conclusion is the same. The system locks itself in with each renewal. The supplier is now a structural feature of the network, not a vendor. Removing it would require rebuilding compatibility across every station, junction, and depot nationwide. Technology evolves around the network but not inside it. Newer approaches exist elsewhere. The installed base makes adoption of any alternative structurally costly. A major modernization program is announced. Planners must now choose between replacing the specification or building new infrastructure around the same constraint. The modernization is built around a legacy specification. The old constraint is preserved at the core of the new system. The dependency moves forward intact. The new investment embeds the constraint one generation deeper. The accumulated cost of eventual replacement grows with each layer of new infrastructure added above it. External auditors eventually quantify the total replacement cost. The number is not a result of mismanagement. It is the accumulated product of compounding decisions made across decades. No single decision caused this outcome. Each decision was locally rational. The cost emerged from the structure of the system, not from any individual error. A formal replacement program is finally initiated. The timeline spans 15 years. The cost is distributed across multiple budget cycles to make it administratively manageable. During the replacement program, the original supplier continues to provide legacy parts. It holds the only qualified production line for components not yet replaced. Prices continue to rise. The replacement program runs over budget. Compatibility testing reveals unforeseen interactions between old and new components at shared junction points across the system. Each adapter adds cost, adds maintenance burden, and adds a new failure point. These were not in the original replacement budget. They emerged from the incompatibility already present. The total cost of the program expands across decades of operation, maintenance, and adaptation. The original procurement decision participates in every line of that total. The system now operates with a mixed specification. Old and new components coexist in the same network. Maintenance requires expertise in two different technical lineages simultaneously. Training programs must cover both systems indefinitely. The workforce carries knowledge of a constraint that no longer makes technical sense but cannot yet be retired operationally. The constraint that began as a procurement shortcut now shapes workforce policy, training investment, maintenance scheduling, and capital planning simultaneously across all regions. The network operates. Trains run on schedule. The cost is distributed, embedded, and invisible in daily operation. The original decision continues to function as designed.